Everybody say hi, Angel. They're not excited. Okay, anyway. Operations on functions. Operations are add, subtract, multiply, divide, along with composition, which is fog and goff. Okay, composition, fog and goff, where you stick one inside of the other, okay? Those are the operations that we're doing. Also, along with that, domains of each one, which is kind of yucky. We might skip some domains because you guys know how to do that. These domains are a lot uglier and a lot trickier than the domains that you'll have on your homework assignment. Okay, you might have like one that's really bad, but the rest of them should be, for the most part, pretty darn easy. Sum and difference, okay? So A just says if F is this and G is this, you are wanting to find the sum and the difference. So you are wanting to add F and G together, and you're wanting to subtract F and G. So if I add, I'm just going to do the addition one. The square root of 9 minus x squared, I'm adding that to the square root of x minus 2. Can I simplify that?
No.
Can I put them together?
No.
How's it come?
Because they don't go together.
They don't go together. They're like an x squared plus an x cubed. I can't put those together, right? They have to have the same thing underneath of the bar in order to be able to add together. So that is literally the addition. Okay, the subtraction is going to look pretty darn similar to that. The square root of 9 minus x squared minus the square root of x minus 2. Okay? And then they ask for domain, which is the icky part. So we have domain of each one. Blech.
Domain.
Blech, blech, blech. Now, the domain, the plus versus the minus should not switch the domain. So as soon as we find this guy's domain, I'm going to guess that this guy's domain is the same, correct? Like the only thing that changes is this plus or minus, and that should not switch my domain at all, okay? So let's talk about domain real quick. Two things that screw up domain.
Divide by 0.
We don't want to divide by 0, which is not involved here.
Negative in the square root.
And then the second thing is a negative inside the square root. Which one is the easy one out of those two?
0.
Dividing by 0. This is the easy one, okay? This one is a little bit harder because we usually have to use a number line in order to figure out what x can and cannot be, okay?
Cool.
So here's what we're going to do. Here's what we're going to do, okay? I'm going to find what's called the critical numbers. We called them critical numbers before? Yeah, critical numbers. Okay, so I'm going to find the critical numbers. I have two square roots. So I have this one and I have this one. How do I find critical numbers from those?
0.
Set them equal to 0. So 9 minus x squared, I'm going to set him equal to 0, okay? And then what?
You just solve.
You solve. How? I like to add over the x squared first,
And then you take the
right?
square root.
9 equals x squared, and then take the square root. What's the square root of 9?
3.
Kinda.
Plus minus 2.
Plus minus 3. So I have two critical numbers there, okay? If I set x minus 2 equal to 0, x equals 2. So I have three critical numbers, okay? Three critical numbers. And I put them on a number line. I erased your we hate number lines, or we are outvoting number lines up
Yeah,
here.
no, that's kind of
Ha! Negative 3, 2, and positive 3. Those are my critical numbers. I put them on a number line. Okay, then we test some points. On the left of negative 3, what would you like to test?
Negative 4.
Negative 4. In the middle.
0.
0. In the middle of 2 and 3.
2.5.
And beyond 3.
4.
4, sure. Okay, we've got to test those points. All right, so we're going to plug them in and just see if they give us problems, right? So if I plug negative 4 in here, okay, negative 4 squared is what? 16. So this would be 9 minus 16, which is
No good.
negative, which is not good. I don't even have to plug into this one. He already fails over here because I can't have a negative inside a square root. So that's bad. I don't want negative 4. Okay, good? Now I do 0. If I plug 0 in, 9 minus 0 squared, is that going to be okay or not? 9 minus 0 squared
It's okay.
is okay. What about 0 minus 2 squared?
Not okay.
Not okay. So I can't have that. Okay? Now 2.5. Let's go back to 2.5 here. Do you know what 2.5 squared is?
What? 6.25.
6.25. Okay? So 9 minus 6.25 is going to be a positive number. That's okay. Good. And 2.5 minus 2 is 0.5. Can I take the square root of 0.5?
Yep.
Yeah, it's ugly, but it works, right? So I can have these numbers.
Yep.
Okay, and then let's plug in a positive 4. So if I plug in positive 4, 4 squared is 16 again. 9 minus 16 is negative. I don't want that 4 in there. So I am only allowed to plug in numbers that are between 2 and 3. So 2 comma 3 would be my domain. And now we have to decide whether the brackets are parentheses. Can I plug 2 in? Exactly. Can I plug the number 2 in exactly? Like if I plug 2 in here. This would be 9 minus 4, which is the square root of 5. That's okay. That can work. 2 minus 2, that is 0. Can I take the square root of 0? Sure I can. Okay, so I can plug 2 in, so I'm going to put a bracket. What about 3? Can I plug 3 in here?
Yeah.
3 squared is 9. 9 minus 9 is 0. Can you take the square root of 0?
Yeah.
Yes, this would be the square root of 1, so that works. 2 comma 3, I can plug those numbers in. Okay, that is the domain for this guy. What's the domain for this one? The same thing. The minus is not going to change it, what I can and cannot plug in, right? It's not going to change the domain anyway. It'll change the outcome, but it won't change the domain. Happy with that? Like that was kind of unpleasant, but find your critical numbers. Excuse me, find your critical numbers and then plug them in. Good?
Can we not find the domain? Oh, number 5. On the test today.
You have to find the domain on like one of them on the test today. And it's not that hard.
So for 3 and 4 on the homework, we don't have to find the domain of those? Because it doesn't say to find the domain.
Then don't.
Okay.
Okay. All right, next. Write the rule for, what does this mean? Right here. FG. That means multiply, F times G, okay? There, in a little bit, we'll get to this guy. This does not mean multiply. FOG does not mean multiply, okay? That's F composed of G. FG, right next to each other, means multiply. All right, so here we go. We have the square root of 3x. Wait. Let me get rid of this. The square root of 3x times, I don't know why I put that in parentheses. Let me erase. Start over. The square root of 3x times the square root of x squared minus 1.
Lovely.
Can you put those together?
No. No, Coacher, I will beat you. I will slash all of your tires, take out the battery.
You can't.
We will all compromise. Ready?
No.
We'll put them under one roof, but we won't multiply them together.
There you
So
go.
we'll do that, okay? Can we agree to do that? Okay, I won't make you foil it through or distribute it through, but we'll do that, okay?
You just put
Happy
them-
with that? I just put them under the same roof because you can multiply things if they are not the same. I just put them under the same roof, okay? So that's what he looks like. Now dividing. F goes on top. That's 3x. On the bottom, x squared minus 1. Okay, then what? Can I do anything with that?
Nope. You can square
Kind
it.
of. You can't square it unless it's equal to something.
Or, yeah.
You can put them all under 1 though. If you want to do one solid square root, that's what that means. So
Well,
this is f divided by
Do
g.
you want us to do
This
that?
is that.
Does that really matter?
I'm not going to count it wrong if you don't.
No,
That's
I
fine.
already did it.
Okay. Now we have to talk about domain. Poo.
X can be 1.
Domain and domain and domain and
Domain
domain.
can be plus or minus 1.
Okay, so to do domain, you're right.
What?
You're kind of right.
What do you
Okay,
mean? Kind
so
of
to do domain, I just set 3x times x squared minus 1. I set that equal to 0, right? Okay, now he's already broken down. There's a reason why I didn't multiply them together. I'm going to set 3x equal to 0, and I'm going to set x squared minus 1 equal to 0. Okay, good? Yeah?
Wait, I need it.
Okay, if 3x equals 0, x equals
0.
0. That's one critical number. If x squared equals 1, I add the 1 over, right? Okay, and take the square root, x equals
Plus minus 1.
plus minus 1. So I have how many critical numbers?
3.
Tres más.
What?
Negative 1,
Hey,
0, and 1.
when we graph, isn't 0 count as 2?
No, because it was only like 3x. If it was 3x squared, then 0 would have a multiplicity of 2. Okay. All right, so now we plug stuff in. Blah. Gross. Let's plug in negative 2. Let's plug in negative 0.5. Let's plug in positive 0.5. And let's plug in positive 2. Okay? Boo. Boo, boo. Do we want to separate this out? Like have some of you plug some in?
Just
Tell me what works and what doesn't work.
use your big brain.
Negative 2. Ugh. Yuck. Okay. Negative 2 is not going to work. Because it's going to be negative. Negative 0.5 may work. What's 3?
Wait, whoa.
What? What?
It's x squared, so everything negative.
No, but then this would become -6 times a positive.
That's stupid.
Right? Okay. All right, 0.5, -0.5. This would become, okay, -0.5 times 3 and -0.5 squared minus 1. -0.5 times 3 is a negative number. -0.5 squared minus 1 is another negative number. So I have a negative number times a negative number, which is a positive number inside of a square root. Yes or no? I can, yeah, it's going to be a positive number. Okay, all right, moving on. We have positive 0.5. I can't. I'm just going to erase the whole thing. Positive 0.5.
Yes.
And positive 0.5. Okay, this is going to be positive. What's positive 0.5 times a negative, or positive 0.5 squared would be 0.25 minus 1 is a negative. Negative times a positive is a negative. Good or bad? Bad. 2, if I plug 2 in, good. I'm going to give you that. Okay, so the domain, -1 to 0, union with 1 to infinity. Okay, I know that infinity has a paren, but what about the other ones? Can I plug -1 in exactly? Yes, that's going to give me 0. Can I take the square root of 0? Yes. 0, if I plug 0 in, it's going to give me 0. I take the square root of 0. 1, if I plug it in, I can do that exactly. So there's that. This is the domain for that guy. Boo. Yucky. Whew. I don't want to.
Huh?
I don't want to.
Yeah, just tell me.
Okay, if I set the top equal to 0, my critical number is 0. If I set the bottom equal to 0, my critical number is plus minus 1. Yeah? Okay, so on a number line, I have -1, I have 0, I have positive 1. Okay, and we do the same thing again. -2, -0.5, positive 0.5, positive 2. Okay, -2. -2. Is he going to have a negative inside of a square root if I plug -2 in for x somewhere? You tell me. If I plug -2 into like here somewhere,
Maybe 4 minus 1. What?
is he going to have a negative inside of a square root if I plug -2 in?
Yes.
Where?
The bottom. And the top.
-2 squared is 4 minus 1. This would be positive 3.
Okay, but the top one would not.
But the top would be -6, right? So I can't have that. So this is a no. What about -0.5? -0.5.
Is no.
Still a no. -0.5 times 3 is going to still be a no. So that's a no. Positive 0.5. Positive 0.5. Positive 0.5 isn't going to give me problems on the top. 0.5 times 3 is not a problem. But 0.5 squared minus 1. Is that negative? 0.5 squared is 0.25 minus 1. Negative. Okay, what about 2? It's good? 2 is good? Perfect. Okay. Now, can I plug 1 in exactly? Because like this would be going from 1 to infinity, right? Is 1 a bracket or a paren? 1. Okay, let's check. 1. This would be the square root of 3 on the top, right? On the bottom, this would be 1 squared minus 1, which is 0. Can you take the square root of 0? So is it good or not good? Where is the 0 located? On the bottom. It's on the bottom, so I can't have 0 on the bottom there. So 1 is a paren, not a bracket. The 0 is on the bottom. That's the only exception to the rule.
Hold on.
Woo! Okay. All right. There we go. Good deal? These are ugly domains.
On all our domains.
Poop. What?
On all our domains, if we just say like, if it's just like one thing, it can't be the base of.
You could just say x is not equal to that. Yep, that's fine. Yep. All right, good. Next,
5.
How do you do 5?
we'll do this part and then we'll stop. How about that? I'll quit early. Okay. We'll do example 3 and then we'll stop.
I don't know how to do
Good.
5 and 6.
Angel, by the way, tomorrow all the juniors are gone to UNK,
I don't know how to do 5 and 6.
so I won't be sending you a video tomorrow. Okay. All right,
this is
composite
third.
functions.
Right.
All right, composite functions are my favorite. I like to talk about composite functions, at least to my algebra kids, because I always use this as an example. Ready for this? I used to work in Herberger's when I was in college, and I would have people that walk in with like something that's on sale for 50% off, right? Okay, and then they'd have a coupon on top of that they can use, right? That is 25% off. Okay, I know I did. And they would walk in and want to buy something that's $100, and they would not understand. They would not understand why it's more than $25. They don't get it because they're like, this is 75% off. But the problem is, you do not stack these coupons. They do not get added together. Because if that were the case, if you had something 50% off and you had a 50% off coupon, that would mean that it was free. If you were allowed to add them together, that would be free, but it is not free. If you have a 15% off of $100 and a 50% off coupon, how much is that thing actually going to cost? What's 50% off of 100?
25.
That knocks it down to 50, and 50% off of 50 is going to knock it down to 25. Yeah? So,
said the coupon was 25%. No, you're good.
I don't know. Yes, up here I did. But then I switched it to 50-50 because this one is easy to see that, like, obviously you're not going to get something free, right? So if I switch it to this, you can obviously see that's not going to be free. But, like, people don't understand why this is not $25, right? Okay, so there's how this works. So F composed of something, like F composed of G or G composed of F, means you're taking one function and you're sticking it inside of the other. Now, I want you to look at these 4 real quick. A, B, C, D. These are really fast. A, B, C, D. And there is a difference between A and B versus C and D.
Yeah.
What's the difference?
G of F compared to F of G is.
Kind of.
Oh,
Like, what do these two have in common?
Their numbers, and you're plugging in numbers compared to.
Okay, here we're plugging numbers in. Ready? Okay, if we're plugging a number in, what you can do is you can cheat. You can take that 2 and you can plug it into F and find that value, and then take that value and plug it into G. Does that make sense? So what I'm going to do is I'm going to find F of 2 first. Okay? F of 2 means I'm plugging 2 in for F. This is my F function. So 4 times 2 squared plus 1. What does that make? 17. Okay, now I'm going to take and find G of 17. Okay, it's like you're working from the outside in. Okay, G of 17 means 1 over 17 plus 2. I'm just going to leave it as that ugly fraction, 1 over 19. Now, my answer is not 17 and 1 over 19. The final answer is 1 over 19. That's it, right? 17 was just getting me to that point, okay? B. Do you want to try B on your own? Try B on your own. I'll give you a head start. Plug -1 in. Don't look at mine until you're done.
I didn't know what it was.
So let's say we have -x squared, right?
No, hold up.
Was
Shouldn't you plug the -1 in for G and then the G in for F?
I did.
So you plug. You just did it in 2 different parts. That's why it's confusing.
Okay.
Okay. That's new. Okay.
Also, how do you do the left side?
So let's say you have x.
I don't know how to do
Yes,
11.
right there.
I think I did 11 and 12
So this
right.
negative
I don't know
chills
how to
out until you
multiply.
square
So you square, so then
So
whatever
So your
you get
answer will be
negative.
negative at the end.
Okay.
Yes.
I have a question.
Yes, sir.
For these, are you just because they're x
Sticking one inside of the other.
and it makes x.
Oh, hey, do you know what happens then? Those two functions are
Equal.
inverses.
Inverse.
Those two functions are inverses,
Inverses,
right? Don't they end
yeah.
up being x if they're inverses? Yeah.
So
But you don't have to note that.
That all
or
of
anything.
that's the answer. Okay. And how do you do this?
Okay, so this is your F table, this is your G table. So here they want you to, I'll do this. Okay, so if I plug 1 in, and I do G composed of F, right? You would plug 1 into F.
It sucks. I
Figure
know.
out what that is.
Then we
and
have,
plug that
then we have
into
to
G,
school
right?
on
So
Monday,
plug
and
1
then
into
we
the
have
F table.
6-day
1
weekend.
into the F table, out pops 3. Now I take
Yeah,
that
'cause
3
we
and
get
plug it
4
into the
days
G
off
table, and out pops
school.
4. So 1 becomes
Break
4.
plus the weekend.
Oh, I
2,
got it.
plug
I
into
can
the
do
F
this.
table, okay? Those ones are fun.
And then
Those
we
are my
have, like,
favorite.
3 weeks of
Okay?
school,
And then
we
how
have
do you do
three-
5 and 6? There you can show me.
Stats
later.
later.
All right, ready?
How about
Did you guys get 5?
Lovely.
Yes? Okay, last thing. When they have G composed of F of X and F composed of G of X, you're just plugging the F function into G or plugging the G function into F, okay? So this is what looks a little bit foreign, all right? Ready? The G function is the outside function, right? Like G is on the outside. So I'm going to start with G and I'm going to go 1 over X plus 2. That was G function, right? 1 over X plus 2. But in place of that X, I'm going to put all of the F function. Like this stuff goes in there, in that spot. So 4x squared plus 1, yeah? And then you simplify as much as you can. So 1 over, what can you do to the bottom? Mm-hmm. 4x squared plus 3, that's it. And I would just leave it like that. Does that make sense? Now the other way around is not going to look the same. The other way around would be if I were to plug G into the F function, right? So I'm taking the G function, which is this guy, and I'm plugging him into the F function, which is really icky.
I don't like this.
Okay, so I start with 4x squared plus 1. That's what it was to begin with, right? That's the F function, 4x squared plus 1. But in place of that x, I'm going to put 1 over x plus 2, and that's going to go in that spot. Okay? And okay, if I square this or take it times itself, 1 squared is 1, right? X plus 2 squared becomes x squared plus 4x, right? 4x plus 4. That's what it would look like if I FOIL it, right? Okay? That's what he is. And now when I would take him times 4, this is like 4 over 1, yeah? So how can I put those two together? If I multiply the tops,
What?
nothing.
It'll be 4.
4 times 1 on the top is 4, and the bottom is just that x squared plus 4x plus 4. And then I'm going to put plus 1 on the end, and I'm going to leave it like that because I don't want to do anything more. Okay? Yicky, yicky. All right? Good?
Hold on, have time.
Okay. All right. You can do quite a few of them on the homework assignment. Especially the ones where you plug the numbers in. Those are really fast. Fast and
I have a
easy.
video from 3-4.
Oh, bye, Angel.
Yeah.